Hi, welcome to Parametric House. In this Grasshopper tutorial, I want to show you how you can produce a series of Voronoi cells using the Kangraoo plugin. This is somehow a modified Voronoi. So as you can see here, I can change the distribution, change the number of count. I can also define pre-existing points. So if I right click here and set multiple points, I can add some points here. And if I change that, that's going to affect the final results. So in this tutorial, we're going to use the Kangraoo plugin to redefine the Voronoi cells. Okay, let's get started from scratch. The first thing we want to do here is to produce a series of Voronoi cells. So I'm going to go to the mesh triangulation and use this Voronoi component. Let me show you the full names so you can see the inputs. We're going to draw a rectangle, simple rectangle in Rhino, and for the boundary, we're going to use that. So I'm going to go to the params menu, pick up the geometry curve, and set this to the rectangle, and we can give that to the boundary. What we need here is a series of points. So I'm going to go to the vector grid and use a populate 2D. And if we give this as the region, it's going to produce random points based on our count and seed we have here. We can give that to the population. For the count, I can save maybe from 3 to 120. I can give that to the count. Let's rename this. And for the seed, it's just a random number, because when you change that, that's going to change the position of the random points. So that's really easy, and you can produce those points using the Voronoi components. What we want to do here is to modify these cells using the Kangraoo plugin. So I'm going to go to the Kangaroo and use the main, and you can use different solvers. You can use the bouncy solvers if you want to see somehow like an animation. You can use the solver to see the results, and a zombie solver is going to make it faster. I'm going to show you with the bouncy solver, then we can replace it with a zombie solver. So I'm going to go here, bouncy solver, and from the params menu, primitive data, I'm going to use that as a goal object. So whenever I want to change the solver, I can just change the output for this one. Okay, we need also a button to reset the solver, and the first thing we need here is in the Kangraoo plugin is the show, because we want to see the lines. And before I go forward, let me show you here that the output is cells, and these cells are polylines. We have to get only single lines for the simulation. So we can go to the curve, use explode to deconstruct them. We have the segments. Then because we have each cell is going to be divided into its segments, you can see that we have groups of data. Let me simplify this. And you can see that we have 47 cells, and each cell has different number of segments. Because we don't need this, we're going to flatten this. So I'm going to just flatten the output, and here you can see that we have all of those segments. If I bake that, you can see that this edge is going to be a duplicate because it's like in both of the adjacent cells, and we have to get rid of that too. To do that, we can go to the curve. The technique I always use is to find the curve middle, for example, and see if the point is a duplicate, because we have a tool in Grasshopper to find a duplicate. So I'm going to go to a vector point called duplicates, give it here, right click and select leave one, and use this index as the ones we have to pick. So I'm going to go to the set list item and say pick up these index we need here, and that's how you can solve it. So instead of 255 lines, we will have 142, and here you can see that we have single lines here, obviously, and that is exactly the set of lines we're going to use in our project. So first of all, we have to show it. So I'm going to add this to the show and add this to the data. So that is the first output we will get from here. Another thing we need here is the anchors. For the anchors, we have to make these points fixed. So I'm going to go to the goals point anchor, and we have to remember to flatten this data so everything is in one group. We have to define the point for anchors, so these are the points. Okay, for the points I'm going to just go to curve and use the start and end points to get all of those points. Let's put them into, with the shift key, into one point. Again, we have some duplicates here because this point is both for this line and this line. So I'm going to go again to vector point duplicates to delete the duplicates and leave one. Okay, so these are the points we are going to work with. And what we need here is to test if they are on the rectangle or not. So I'm going to say curve analyzes point in curve. This is going to test if it's inside the curve, outside the curve, or on it. So I'm going to use that point in curve. Point, the curve is obviously this one. And as you can see here, we have a relationship. And outside, we don't have any point outside, but we have coincident and inside. As you can see here, we have some 2s here, we have some 1s. Because I want to use this as a true false indicator, if I get this relationship output as an x minus 1, this is going to be 0 and 1, which is like true false, especially for the Boolean operation for the dispatching. So I'm going to go here and say, make the expression x minus 1. And now we can use the set list dispatch these points with this kind of true false. This is going to give us a group of true and false. This is actually true, and this is false. Okay, the true and the false. The false is exactly what we need, and we can give that as the anchors. So remember that this is what we are looking for. We can also turn off everything and connect a curve to the output here because the lines are what we are getting here. Another goal we have to add is goals line, and I'm going to use a length line component. The length line component is similar to the goals mesh edge length component. The edge length works with meshes and the goals length line works with lines. The reason we are using this is because it's going to say that each line is like a spring and it can just shorten or just extend to whatever we want. So we're going to use this as our main tool. So I'm going to say length line, give that to the lines here. The length, if none provided, starting length will be used, but we want to reach 0 because we want to make them somehow like a spring. Use the shift key to add it here, and as you can see here, it's like a spring. So they are going to be the lines are going to change location until they reach like a relaxed state, and that's how you can make it. So if I just change the number here and distribution, we have to reset to see the final results. Because we don't want to change this each time, instead of a bouncy solver, I'm going to use the main zombie solver. Just give it here, we don't need a button, and just give that as an output. And here you can see it's great because you just can change the distribution, get output and the different outputs you get. If I change the rectangle, I'm going to get different results. If I want to add new points to the Voronoi, I can just add, use the shift key to here and just say I want also these points. And remember to flatten the input so all of them just run in once. This is also going to affect the final results. So this is also possible. I'm going to clear the values because we just want to start with random points and distribution, and we can get the final results here. And that's the tutorial. So if you want to also use the cluster, just download it from our website, and you can right click here and set the rectangle here. If you want to add additional points, you can do that here, and you can get the output from the curve. So you can see it's exactly what we have done here to get the final results. I hope this tutorial was useful. Remember to like this video and share it with your friends. Hit the bell notification so you get notified about our new videos. And thanks for watching. See you next time. Bye.